All right, kidlets. Last notes of the year for field ecology. Just wrap up really quick. We got done with the Lentic Systems, more or less. Hopefully, learn something about how we put them together and how we research them with biotic indexing and chemical parameters and Black Earth Creek and that kind of stuff. The last thing we're going to look at here is Lentic Systems. This would be the part of the unit where we would take our full day field trip to Devil's Lake, but I want you to do that anyway. When parks are all open, which I think they are now, go visit Devil's Lake, and I want you to try and figure out what type of lake it is. So, to start off, Lentic Systems. A lentic system is anything that's standing water, pond or lake, whatever. There's two rough definitions of a lake or a pond. I mean, they're kind of just layman's terms for what they are. They're really, you could call anything a lake or really anything a pond. So standing body of water, deep, definitely not technically a wetland. All right. It's definitely a lentic system. Okay. Now we got different lake types, and this is what would be really, really cool about this lab is that, we've got these three lake types called lagotrophic, eutrophic, and mesotrophic. Now, as you can see here, these three different lake types have to do with the nutrient supply. Now, why this would tie in so well to the California field trip is because most of the time the bedrock has a massive importance as to the nutrient level that exists or the biotic growth and the epicosystem diversity. A lot of it has to do with like I said, the bedrock. So if we think about it, if you ever been to Devil's Lake, everybody loves going there because that water is really deep, clear. It's often cold, but it's clear, really beautiful looking lake. It's not, cloudy and murky and green like a lot of lakes in Wisconsin are. So that's why a lot of people are going to Devil's Lake. Now you go to, a lot of your other lakes like Fish Lake and Crystal Lake, Lake Mendota, when Lake Marion is full. They're really murky. They get warm. They're dark, whatever. You just don't see much out of these things. But they also have lots of life in them. It all has to do with the bedrock around it. So, for example, why this would have tied in really well with the California field trip is because if you remember right, the bedrock for Devil's Lake is quartzite. How hard is quartzite? Extremely hard. Does not erode. Remember, it's 1.6 billion year old quartzite from the Pinokian Range. That water does not have many minerals in it. Does not have any nutrients. When there's runoff, it doesn't run into the lake. Guess where it's very, very, very similar? Well, when you head out to Yosemite, and that's granite, same basic thing. That's why those lakes and streams and rivers are so crystal clear that we could have done a real nice tie-in of those two lakes together. Why that's a freak for Wisconsin? What is the rest of the state covered with? Most of it. Sedimentary rock. And what does sedimentary rock do real easy? It erodes. And when there's runoff, it runs into a lake. Makes really good soil. Hence, a very rich eutrophic lake. So a lot of the lakes in our area, most of them in Wisconsin, are eutrophic. And lots of fish and wildlife and game and whatever else. But what's really bizarre, why people come for hours and hours around, is because Devil's Lake is a lagotrophic. And it's a mountain lake in the middle of Wisconsin. Very rare. And so we get this situation where there's very few nutrients. You get really clear depth, that kind of stuff. You still have your fish and whatever, but you just don't have the numbers you might have in a eutrophic lake. So guess what our lab would have been going up to Devil's Lake? It would have been to determine. I wouldn't have told you what type of lake it was. We'd have done this, the lake types for the lab first. And you guys would have done the research, and then you would have tied it into the Black Earth Creek, tied it into Yosemite, the Merced River, and all that kind of stuff. And again, the whole idea is that it's all based off of the bedrock. And that's why whoever was doing, I think it was Brady, was going to do the project on the Merced from up in the mountains all the way down to the valley floor where they grew all the vegetables. You were going to see this nutrient load really, really pick up. Not a bad thing always, but the water definitely gets darker and more murky and a lot more nutrients in it. Okay. So anyways, those are the differences. And so we're going to do a little lab later on, well, actually just last week, is next week, we'll wrap everything with a very simple lab, looking at things we actually would measure on Devil's Lake. Okay. Now, a couple of things that happen with lakes every spring, okay, and every fall is something called turnover. Oh, come on, you stupid thing. Oh, why is it freezing? There we go. Turnover. Now, what happens with turnover? Turnover is something that occurs when, obviously, when you heat up water, water's like air, it rises. When you cool water, water's like air, it sinks. And so what happens is you get these stratified layers in a lake. You get this something called a thermocline, where you get this, depending on the time of the year, you get the colder water on top or warmer on the bottom, depending, like I said, on the year. Now, that thermocline is what you guys, when you go swimming and you feel that ice cold layer with your feet in the hot summer days or whatever, that's called the thermocline. And that sets it up. And it's very, very important for lake types and how they function. Now, what happens is in the springtime, well, actually, let's go to fall first. So in the fall, let's say all summer long, it's nice and hot. You got your thermocline right here, okay? Now, that water was nice and hot. It's higher than 4 degrees Celsius. So that's going to be, it's going to be probably about 36, 38 degrees Fahrenheit. Nice and warm, or warmer, it's going to be on top. Okay, there's your thermocline. Now, as the fall goes on, what happens to this top layer? It gets colder and colder and colder and colder. Now, eventually, it will freeze. And we all know that ice floats, right? So what happens before the ice freezes is this gets so cold that it reaches a point that it hits 4 degrees Celsius, and that's the densest that water can possibly get. Guess what the water does at 4 degrees Celsius? It sinks to the bottom, and the bottom water rises to the top. Okay? That is turnover, and it's very important, and it really kind of cleans the lake and brings up all the nutrients, takes oxygen down below. It's a huge dealio. So the cold water at 4 degrees Celsius sinks because it's more dense, and the water down below is actually warmer, and it rises up. So now in the springtime, the opposite occurs. There's your ice on top, right? Okay, it's really cold, but when it's ice, water has a unique property that it floats when it's frozen. So now when that ice melts, it's at 0 degrees and 1 degrees and 2 degrees and 3 degrees. All of a sudden it hits 4 degrees when that ice water, or that water is now, ice is melted and that water is now 4 degrees. It sinks and the whole thing rotates. So it's really kind of a cool concept with what's going on in in a lake. So this stuff here, well, it gets that warm, or it warms up, it sinks to the bottom water goes to the top. All right, and those are really important aspects of how a lake actually moves. Okay, all right. I think what we'll do is we will finish up with tell you what, let's just finish it now. No, we'll come back next week, and I'll do a little bit of this. So let's split this up. This is 8 minutes already. I'll split up, and we'll do the rest of the notes, just a little bit on Monday or Tuesday, and just wrap up what we mean by something called eutrophication. Okay? This is really, really important right here. The rest of this is so on or whatever, but this one right here has to do with, human activity. Okay? All right, so we'll do that, and we'll do a little bit of a lab starting on Friday, 1 or day 2, 2 days, whatever else, and then we're going to wrap up the year. All right, later.